So lastly, I want to talk about how we can make vertex form out of a standard polynomial form when we have an a value other than 1. Makes it just one extra step, a little more, just a little more complicated, but not too bad. So what we have is a 4x squared minus an 8x. And again, we're going to kind of ignore this c term. We're just going to have it off to the side. But essentially, to complete the square, I have to have a 1 in front of this. So what I'm going to do is I'm going to factor out a 4 from all of my x terms. So I'll get a 4x squared minus 2x. But then I'm going to leave that space like I did before, and then I'm going to have that minus 13 on the outside. Even if I can factor 4 out of it, it's not even worth it. But I'm going to do the same thing that I did with completing the square. I have the x squared minus 2x, and I got to find that magic number that I can absorb into a perfect square. It's still the same thing. So I'm just kind of ignoring the 4 for a second and complete the square with the thing on the inside. So I'm still going to take half of b and square it, which in this case, half of 2 is, or the half of negative 2 is negative 1, and square it is adding a 1. Okay? Now before, when there wasn't a 4 in front, I would instantly subtract 1. And that's probably going to be the common mistake that we're going to have. But we got to think about what placing a 1 there did. I didn't add 1 to the equation. Really, by writing a 1 there, I added 4 to the equation because the 4 is on the outside. So by placing a 1 there, I'm adding 4, which to keep it balanced, then I just have to know that I have to subtract 4 total from there. So I still have the 4 on the outside, but I can factor these 3 terms pretty easily to just x minus 1 squared. And then I just take my negative 13 minus 4, which is a negative 17. And then I'm in vertex form. If I wanted to find the vertex, it's at 1, comma, negative 17. Which I think you would agree, if I look at this, 4x squared minus 8x minus 13, it's pretty hard to see where the vertex is. Now I can tell it's a max or min based on the a value is positive, so I know this is a minimum. I can start to find other pieces like x and y intercepts, which I think, again, for this one, it doesn't factor, so you could use quadratic formula. But honestly, if I'm looking for x-intercepts, add 17, divide by 4. I can take square roots. It's a lot easier algebra to solve in vertex form. But that's my opinion. But it just adds one more step if there's an a value in front that you have to take care of that first.